Now we will solve the worksheet of Chapter 11, the capital budgeting. In this worksheet, we have two projects. We have project A and we have project B. For these projects, we have an initial investment of -110 for project A and an initial investment of -130,000 for project B, and with cash flows over 5 years for both projects and with a weighted average cost of capital of 6%. First, we have to calculate the net present value. As we know, the net present value is the sum of the cash flows. So here are the cash flows of the project A and the project B. So it is the sum of the cash flows discounted at 1 plus K. The K is the weighted average cost of capital to the power T, which is the years of the project. So first, in order to solve the net present value for project A, so first we start -110,000, which is the initial investment for the project A, plus the cash flows of project A, which are 25,000 for year 1, discounted at 1 plus weighted average cost of capital, which is 0.06, to the power 1, which is the year of the first cash flow. Then 25,000, which is the cash flow for year 2, discounted at 1 plus 0.06 to the power 2, which is the year of the second cash flow, plus 40,000, which is the cash flow at year 3, discounted at 1 plus 0.06 to the power 3, which is the third cash flow or the third year, plus 40,000, which is the fourth cash flow, discounted at 1 plus 0.06 to the power 4, which is year 4, plus 50,000, discounted at 1 plus 0.06 power 5, which is the fifth year. So the NPV of project A will be 38, which will be $38,466.2. Same process will be repeated for the project B. The initial investment is -130,000 plus the cash flows 50,000 for year 1 discounted at 1 plus 0.06 power 1 plus 40,000 discounted at 1 plus 0.06 power 2, which is the second year, plus 30,000 discounted at 1 plus 0.06 power 3, which is the third year, plus 35,000 discounted at 1 plus 0.06 power 3 power 4, which is the fourth year, plus 45,000 discounted at 1 plus 0.06 power 5, which is the fifth year, and the NPV for B will be $31,835.5. So that's for the how we can calculate the NPV. Then, in order to calculate the MIRR, which is the modified internal rate of return. As we know, the step 1 in order to calculate the modified IRR is to calculate the future value of the cash flows generated by the project. The future value, which is the sum of the cash flows into 1 plus K to the power n minus 1 or n of a future. So, and step 2 is to calculate the MIRR according to its formula that is known by the future value, which is the calculated from step 1 over present value, the present value which refers to the initial investment of the project, and we put it using a positive value to the power 1 over n minus 1. So if we want to calculate the MIRR for project A, So referring to the cash flows of project A, first step is to calculate the future value of the cash flows for project A. So the first future value, we look only to the future values starting from the time 1. So these are the cash flows that are generated, and we should calculate the future value of these cash flows over these years. So we start first from 25,000, and this 25,000, according to the future value formula, it should be multiplied into 1 plus 0.06, which is the weighted average cost of capital, to the power 4, which is n of a future, since from 1 year to 50 year we need 4 years, so to the power 4, plus 25,000, which is the cash flow at the second year, into 1 plus 0.06 power 3, which is the n of a future, since from the second year to the 5th year we need 3 years. Then plus 40,000 into 1 plus 0.06 power 2, plus 40,000 into 1 plus 0.06 power 1, plus 50,000 into 1 plus 0.06 power 0, since we already reached the future. So the future value will be equal to 198,680.9. Then the MIRR is known as the future value, calculated future value, divided by the initial investment in its positive value to the power 1 over n, all the formula minus 1. So it's equal the future value that we have divided by 110,000 to the power 1 over 5 minus 1. So we will have the MIRR for A 12.55%. And the same process will be repeated for project B. So we calculate first the future values of project B, starting from year 1 till year n, and we put the power to the future. So the first power is 4, the second power is 3, the third power is 2, the fourth is 1, and the fifth is 0. And we have the future value for MIRR equal $216,572.4. Then the same formula for MIRR can be repeated. So it's equal to future value of the cash flows discounted or divided by the initial investment in its positive value to the power 1 over n, all the formula minus 1. So it will be equal 10.75%.